So hi everybody, and I'll try to keep you entertained in this sort of coveted before lunch spot in the talk. So I'm Guy Pojarni, or Guypo, and I'm here today to give you a talk that I sometimes call Secure Node Code and sometimes call Stranger Danger, which deals with some node-specific advice around so securing things in this ecosystem, as well as a general theme or concept about vulnerabilities in open source packages. So a little bit about me. I started with security, a daunting number of years ago now, sort of showing my age a little bit, about 20 years through the Israeli sort of cyber security army, and then I've been in AppSec for a good sort of 17 years now, I guess, or 16 years, working on AppShield and AppScan, the first web firewall, web app security scanners. Then I left security, which is an unusual move, and started a performance startup called Blaze, which got acquired by Akamai. I was CTO at Akamai for a few years. And then I've recently left that to found another startup called Sneak, which is where I am right now. So open source is awesome, right? I think that's pretty well accepted. It lets us share our work when we create it. It lets us reuse the work from others and therefore focus on our core and makes us very productive. And as a result, open source has exploded. The use of open source has gone from something that's more rebellious, more sort of, a few small entities, except for maybe the major exceptions for Linux and the likes, to things that is really prevalent across any organization, including banks and the others, just about how much of it you use, not whether you use it. And unfortunately, we get these constant reminders that the fact something is open source does not mean it's secure. That may or may not have been true earlier on, that because it's open, there's eyeballs on it and people scrutinize it. But it definitely isn't true today with the volume of activity that's going there. It doesn't mean open source is insecure. There's all sorts of pros and cons, but it definitely is not implicitly secure. And again, we get all these like brand name vulnerabilities, designer vulnerabilities that help us reminder of it, right? Like Heartbleed and Shellshock and Logjam. I love this sort of Cloudflare animation there, the log and a jam. That's kind of the best they can do. And the other thing that happens about open source is that attackers are targeting open source. It's a very lucrative target. It's one vulnerability, it has many victims, it is everywhere. So it's a very appealing one, and therefore there's all sorts of stats, but the majority of successful exploits are attributed to some form of unpatched servers or unupdated open source components. And there's a lot of conversations, like the one we had earlier today from Matt, on how to handle this, both on servers as well as on more modern environments like containers. And all sorts of studies show that it's a very real problem and that it's just continuing into this new world with binaries of containers where 30%, this is one analysis, again, different views, but definitely many of the containers out there in repositories contain these types of vulnerable binaries. And alongside it, although, as we've just heard, it's not easy, there are at least some solutions. There's a lot of conversations around how do you tackle that in terms of updates, in terms of container security tools. There's kind of growing chatter there. But all of that is about open source binaries. What about open source packages? Open source packages that get pulled into our code. They're just as hacker-friendly, a lot of sort of usability taken into account there. The vulnerabilities are already found for you. You don't need to work. It's just sort of there by the community. You just need to write an exploit, and it's kind of easy because you can download it to your system. They're everywhere, millions and millions of downloads a month. That's true for packages and binaries. And they're hard to update, in part because of dependency chain, and this thing depends on the other, and what's in memory. So in code, it's, what is the dependency component? Things are out of your reach. And in part because of fear, right? We think that you might trigger some breakage, some functional limit. And then lastly, it's sort of pulled in across the system. In the case of binaries, it's servers everywhere. And in the case of code, it's all these applications where any developer has the legitimate mandate to pull in another piece of package that to sort of work efficiently. So for the remainder of the talk, we're going to pick on Node because it's fun and because I sort of have some tools to show on it. But really, this problem is prevalent. It's not just sort of a Node problem. So within Node, the package repository for open source packages is called NPM, and it is awesome, and it is growing at an amazing pace that forces me to update this slide every time I give a talk like this with some other staggering numbers, like 6 billion downloads a month. I mean, that's a fairly impressive number. And this is more than double what it was, I guess, about 9 or 10 months ago when I just sort of started quoting these stats. It also has over 65,000 publishers. I think it's actually more like 70 or 80,000 right now, which shows the strength of the community that's sort of pushing in this content. And what that leads is to the situation where this is your app, and this is your code. And at first glance, you might think that this is a negative slide. But I actually think of it as a positive slide. You can create all that orangish value with only that purplish level of effort that you need to do, that you need to actually build in. So it's a good thing. It lets us run faster, lets us be competitive, be innovative. But it's also a scary one, right? While on the functional side, it says that JavaScript has won, as many of the JS people like to say, but again, this is through other environments. From a security perspective, each one of these dependencies is a security risk. And when you stop to think about it, there's a lot of daunting questions. I mean, do you even know which open source packages are you using? Do you know for every single one of them, did the developers writing it have any sort of security expertise? Did it undergo any sort of security testing? Keep in mind that security tools are generally oriented at enterprises, and many of these packages are written by 1, 2, 3-person teams, written on a weekend, and sometimes, well-maintained for a period of time and then kind of neglected. Not sort of the same model as security assessments have been done. And oftentimes these people have no security expertise. And maybe more practically, do you know if they have known security bugs? Packages have bugs, it's been known to happen. And some of those are security flaws, just like the binaries. So this is sort of the code part of what you're pulling. And then the second concern there is the people part. There's a lot of greatness, again, in the open source world, that open source is written by people. It's a community of people. All the solutions and all the opportunities are about people. And it's easy to forget that these people are strangers. We don't know who they are, and yet we pull hundreds and thousands of packages written by tens of thousands of strangers from the internet, and we run them in a financially sensitive environment based on, at best, minimal scrutiny. So it's scary. And while we like to think that these are all like benevolent ponies, definitely in the NPM ecosystem, we in this room know that they're not. Some of them, maybe the vast majority of them are, but there are bad actors out there, right? There are people that are trying to do something bad. And once again, we don't really know those users. We don't know if they're malicious. We don't know if they've been compromised. How well do they treat their development environments. We've seen some examples on this on mobile development with Xcode Ghost and a recent vulnerability in the Play Store, where developers were distribution vehicles for viruses. These were pieces of malware that attacked developers of Xcode or Google Play, of iOS or Google Play apps, and injected malware when those apps were submitted into the App Store. And the true victims, or the true target for the attacker, were the users, but the developers were used as a distribution vehicle. And it's a very efficient distribution vehicle, and unfortunately a fairly hackable distribution vehicle today. So this is a bit of a doom and gloom, and it's a big problem, and I think it has no single sort of silver bullet, and it needs to be a bit of a community solution, and there's a lot of conversations going on it. For the rest of the talk, I'd like to focus on what I think is the most concrete aspect of it that we can start doing in the open source packages world, and that is known vulnerabilities, right? In the world of NPM, about 14% of the NPM packages that are out there right now, the latest versions, carry a known vulnerability. Either they have one in their own code, or they pull in another package that has that vulnerability in it. We at Snyk, we deal with this, and we see that about 4 in 5 Node development shops, when they go in and they start to test their applications, on first glance, they find a vulnerable package, at least one that they're using. And in the majority of cases, these are, or in many of these cases, these are very high severity issues. This is like, I'm not the only one talking about this component. This has been mentioned by Sonatype, by various others. Can have that mandatory Josh Corman mentioned here. He's not here, he is in spirit, talking about calling this software supply chain. You can kind of call it whatever you want, but it needs to be addressed. So I will ask 2 things. First is, how do we protect ourselves from these issues? What processes should we adopt? How are they different than open source binaries? And then second, from a code perspective, I find that these vulnerable packages, because they're so contained, because these are real-world vulnerabilities, they're actually a really great educational tool for developers in our systems to learn from these mistakes and understand how do they avoid making them and how do they address them when they happen in their own code. So the remainder of my session is not going to be here, but what I'm going to do is I'm going to try to kind of demonstrate a little bit why this is a real problem you should care about using a vulnerable application that we have called Goof. It's in JavaScript, so it needs to be a to-do MVC. That's the way it is, and it allows you to do some important note-taking, like call mom, or you can highlight a few things like buy beer, just sort of for emphasis, and use that component. No, it's a simple app, and within it, it uses a bunch of packages, popular packages that are used in the recommended way. So there's nothing, I didn't sort of intentionally, obscure this or mess up with this just to sort of make the vulnerabilities more highlighted. It's used in the naive, in the standard way. And we're going to use, kind of, excuse here the plug, we're just going to use it for info. We're going to use Snyk for it. So this Snyk would allow us to sort of test the different repositories that we have in it, all the different NPM packages. And we will find this one here, Goof, which we can see has a bunch of vulnerable components, some high severity, medium, low severity. And we'll just sort of pick a handful of these going into the test report that, again, kind of try to show the magnitude of why should you care about this. So there's a bunch of vulnerabilities here, and I'm going to pick on a very arbitrary set. I'll start with ST. ST is a package that was created by the author, by Isaac from NPM, the guy who runs NPM, super capable developer, and it has a directory listing vulnerability in it. So let's just sort of get warmed up a little bit. We use ST to serve static resources in our application. So we use it to serve our CSS files, our JavaScript files, as well as our about page, which just sort of highlights how awesome this application is. So we can't really do any hacking in the browser because it normalizes paths for us. So we're going to switch. Is this font big enough? No. Let's try this. And we'll sort of switch to curl, and we'll fetch our little about page. Again, just kind of getting warmed up. And we know there's a directory traversal vulnerability here, so what are we going to do? Suggestions? No? Dot, 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 dot. A bunch of these, and maybe we'll kind of ask for the etc passwd file. The app is kind of running on Heroku. And this will do nothing. Because actually, this is a good package written with security in mind, except, like many pieces of code, it has a bug. So the dot dot is actually sanitized. However, if I did a different way to do dot dot, for instance, %2e, a URL encoded version of it, things would not fare as well. So again, just kind of getting warmed up, just to see. Am I doing this okay here? And, bah. Oh, yeah, there's a missing slash over here, some live coding here, live hacking. Et voila. Okay, so just getting started a little bit. There's actually a handful of vulnerable sort of static resource packages in NPM right now that have these components, and this is one of the top vulnerabilities that we see happen there, which is sensitivity to encodings, just sort of not thinking through. Again, not a lot of security consciousness. Seems like 101 from a security perspective, but many of this is not had a security perspective. Okay, got started a little bit, got our Heroku etc passwd file, which is not that useful these days anyway, and let's sort of go on to the next one. The next one is, and the winner is Marked. Anybody here happen to hear of Marked? Marked is actually a much more popular package. So Marked is a markdown parser, and we use it to be able to highlight beer in our to-do application, which is important, you must admit. And it gets downloaded about 2 million times a month. It's the top, I believe, markdown parsing library in Node. And it has, as we know now, a cross-site scripting vulnerability. So what are we going to do? What are we going to do? Script, alert, 1, script. And nothing. Just like ST, Marked has a very comprehensive sanitize function that's built into it. Now, interestingly, sanitize is off by default. We turned it on in this application to sort of add the security feature, but it's off by default. Similarly, ST allows directory listing by default. So this is another sort of facet of security concerns you should think about with open source packages, which is their insecure defaults. Ongoing conversations, true for binaries as well, around whether that's a vulnerability per se or not, but it definitely is a security consideration you should have, and it's not well documented. So we're sort of still struggling around whether we want to present these as vulnerabilities, but for now, both Marked and ST don't have good security faults. But anyways, in this case, we turned it on, but it doesn't have, this vulnerability. Any other suggestions for variants for cross-site scripting? No? Some encoding. So encoding how? Well, I'll start. I'll kind of do a little bit of a, I'll get you started. So, Marked catches HTML very well, but this is a markdown format that would actually give me an alert or sort of a JavaScript link as part of that page. So if I do this, what'll happen? No, well, let's see, before lunch, you're just too tired. Nothing, because Sanitize is actually very comprehensive, and it catches those concepts as well. But once again, this one has an encoding problem in it. So how can I encode in HTML? No? We need more red teams here. So ampersand, yeah, exactly, HTML entities. So we can do something like this, and something like this, 41, colon. And these are HTML entities, so they're a way to sort of represent to the browser to say this is actually a colon. If I do this, then now I get nothing. And this is maybe a point to say that cross-site scripting is hard to block. Marked is actually has the sanitize function is actually really good according to the spec. However, browsers do not follow the spec as they should. They're actually very, very tolerant. So if I go in here and I add this over here, or just some word, the browser is going to look at this string and say, well, like I know it's not the spec, but I kind of get what you were meaning. You gave me enough hints, I will follow along, and I will think of this as a colon. And if I do this, and voila, we've got our coveted alert, which we just love so much in the world of security. So, these are, the reason I kind of go through this process and all these encodings is to say, just put yourself a little bit in the minds of a newbie developer, an experienced developer, but not necessarily a security conscious one. Just sort of thinking about all these scenarios is hard, right? It's not an obvious thing. And we're consuming a ton of code from these environments. I'll show a couple more examples, and then I'll kind of switch a little bit more to solution mode. Because these are all, like if you're a red team, you're not that thrilled by finding a cross-site scripting and a directory traversal. You're sort of looking for something more hardcore. There's a couple of like remote command executions that are on the way to be published, but I can't show them quite yet. So I'll show a couple of others that are more memory related. So we talked about Heartbleed before. The next vulnerability I want to show you is on Mongoose. Has anybody here heard of Mongoose? Mongoose is really quite popular. So Mongoose is the way to access MongoDB, which is the database or most popular database in the world of Node. And it has a vulnerability due to an object called buffer. Buffer is a very tricky object in the world of Node. JavaScript developers typically don't think about memory, but buffer allows them to actually create an object that holds just a bunch of allocated memory, and it has two constructors. It can take a string like this, in which case it would just allocate that amount of memory into a buffer, or it can take an integer. And when it takes the integer, it allocates that amount of memory, except it doesn't zero it. So at this point, if I've received a piece of input, if I've received kind of a piece of integer, and now I have this object and I somehow managed to get it back to me, the attacker, then I can now read Heartbleed style server-side memory. Now, this is not from OpenSSL, so the secrets will be different. It'll be source code and code secrets versus necessarily the SSH keys, but it's still pretty bad. And actually, depending on how you have your node, it might even be the SSH keys, the TLS keys, sorry. So let's talk a little bit about how this happens here in Buffer. But this vulnerability, Buffer-related vulnerabilities are now in some pretty major packages. So they're in Mongoose, they're in Request, they're in WS. Just to give you a sense, Request gets downloaded 17 million times a month. And we did a quick kind of GitHub query, because GitHub has some of its data in BigQuery, and very quickly found 10,000 projects that use a vulnerable version of Request directly. So it's everywhere. People just don't think about it. So in Goof, we use Buffer as the entity or the element that holds our nodes here. So we're going to again switch to the command line a little bit here. And I've got some aliases here to help me do it. So, just to kind of flow through, I'm going to do this, echo content by beer, and I'm going to use HTTP py just for syntax highlighting. This is like curl, but prettier. So just sort of posts the content, and all we've done here really is switch to a curl, a command that would just add the by beer over here. But because this is Node, typically you can take input in another format. Any suggestions? JSON. Everybody loves JSON in JavaScript. You know, it's so native, it's so easy to work, and super trivial to add. So we can do the same thing, and again, just sort of sparing myself some typing here. You can do the same thing using JSON. I'll just sort of do this a little bit here. And it's the same thing, right? I'm just going to say fix the bike, run this, go in here, fix the bike, right? Nothing all that spectacular. But because this is JSON, I can do another type of manipulation here. Ideas? So in JSON, I can do this, which is just another string, right? If I just do this, then I'll just get an 800 here. But in JSON, it actually typically gets translated to a JavaScript object. So if I remove the quotes, the inferring of the type would happen as part of the processing, or the parsing of the object. So if I do this, suddenly what I've passed is an integer and not a string. And if I call this, and this is just for convenience, we're echo back the note. And if I go in here, I'll see a bunch of binary data. And if I do this enough times, and you know, there's no telling what happens in any specific set, but anyways, if I ran this enough time, I will get, again, the source code, the different secrets from the code. So this is very much a severe vulnerability, and it happens in very popular components, and you'd be amazed at how often they are not updated, because from a developer perspective, there's not a lot of conversation. There's not any conversation, really, about vulnerable packages, and therefore people oftentimes, some people are very upgrade biased, like they want to use the latest and greatest, but there's a lot of also fear of upgrade because you don't want your code to break. You want it to be deterministic. You want to know that you can deploy this and it's the same version again. So people are oftentimes very averse to upgrades. So I'll show one more vulnerability because that is maybe a little bit more relevant to Node. And again, kind of switch up. I think I still have 10-ish or so minutes, which is in MS. And this is maybe the most popular, the most kind of recurring type of vulnerability that we see in our system. We mark it as low severity, a little bit dubious. And what it is a regular expression denial of service. Anybody here heard of RDOS? Regular expression, so some awareness of it. Like clearly everybody knows of DOS, of denial of service. And what happens is regular expressions are, we don't think of them that way, but they are algorithms. And they take a non-linear amount of time to process an input string. Depending on the regular expression, that lack of linearity might be, you know, a very steep curve, or it might be a lighter one, but it definitely is non-linear. So it means that every time you're running a regular expression, if you're not containing the length of the strings that come in, and sometimes even if you are, you might actually make that thread very, very busy for a long time. This is a problem in every language because you can pretty easily occupy a thread and you can kind of get a server out of commission. But it's especially bad in Node because Node's claim to fame is that it's event-based. It doesn't scale on threads, it scales on events. A single thread can process a huge number of clients. So even a massive production application in Node typically doesn't have that many threads running. And so in this case, we use MS, and RDOS happens just everywhere. But we use MS to say something like, you know, call mom in 2 hours. And it would understand MS is just a little package that takes strings like 2 hours and the likes, and uses a very simple regular expression to convert those into the number of milliseconds that would take. So, you know, we support this type of input, but what can we do as an attackers if we anticipate, or in fact we don't even need to guess because we might have seen the package online, that it has a RDOS vulnerability? What are we going to try to do? Put in a lot of numbers, put a very long string. So I'm just going to sort of skip the foreplay here and go straight to it, which is I am going to just echo a long string here. And what I've done is I've just printed 60,000 fives, because if I did another 0, then my Heroku build would skyrocket. And I also made the string almost match the pattern, because you know that's just so much more fun to make the regex run longer. And if I do this, what happens now is, you know, it takes a long time to run. And more interestingly, if I go here and I click or I type, the application is not responsive. And it didn't take much. And if this was a massive application, then I might run many of them. And if this was a serverless application, then this would just hike up a bill. And you know, clearly not a good model. So these are just 4 of, as you might imagine, many, many vulnerabilities. But really the point I was saying here is these are real vulnerabilities. These are not some, make-believe side, this is a theoretical problem that might happen. We see this on real applications, massive applications of large organizations. So let's go back here a little bit. So with that in mind, I'd like to talk a little bit. Oh, actually, you know what? Let's sort of stay here still. And talk a little bit about solutions. So there are several steps that you want to do when you talk about addressing the solution. The first is kind of acknowledging you have a problem. So you want to find these problems. You can use Snyk for Node. You can use OWASP dependency checker. You can use victimsDB in Python. It's still a very new problem. There's a shortage of tooling, but you can kind of find the tool that's right for your environment. Then you want to fix them. Fixes generally happen through upgrades, like they do for binaries, and rarely you also have a patching mechanism like you do for automated updates. Like in the case of Snyk, we build some of these patches for Node. In the case of Ruby, the Rails community sometimes offers some of these patches for Rails itself, so you can look those up. And a lot of this needs to happen, like I will posit that while you need to know about this problem and you need to understand it, you don't want to tackle it yourself. You don't want the security people to do this, but as we've sort of talking about, you want the developers to embrace this. So when you think about whatever tool, live demo here, when you think about whatever tool that you've chosen to integrate, you want to think about how do you want to pull those types of fixes, those types of tests in and make them happen continuously. So again, I'll kind of show you how we do it here in Snyk, which is we found the issues, we can fix them by submitting a fix PR. So we find that that approach in general for whether it's dependencies or other approach is useful. You submit a pull request, there's an actual change. I think Matt mentioned that as well. It's now being tracked. People like closing pull requests. They don't like accumulating a backlog of them. And these have the necessary changes to make the changes go away. And then once you've sort of found the issues and you've fixed the issues and you're vulnerability free, you want to talk about 2 continuous things that you want to do. The first is prevent. You can add tests into the pull request process or into your build process to catch whenever somebody adds a vulnerable package. So GitHub allows you to do things like this, like a test in the pull request that just sort of says, hey, you've just added a vulnerable package, or the equivalent of that is just put it in the build, put some form of test action in the build, so you're catching them when they happen. And then the last step we talk about is respond, and that's be able to track which dependencies you're using and then track vulnerabilities against them. We have a little bit of an advantage here because unlike the world of binaries, which is already very messy and we get a lot of these unnecessary items, here we can try to build and focus our tools directly to the environments and the tools that we use. Again, kind of in our world, we do this via these proactive fix PRs, fix pull requests. So when there's a new vulnerability, we sort of submit one of those fix PRs and notifications. You can build, these are, again, because of the vulnerabilities are very tailored to a specific environment, if you were to build automation around it, you can be proactive about only the vulnerabilities that affect your applications, just sort of test if they exist there. So to recap, kind of stepping out of that, 2 types of takeaways. First is maybe a little bit more specific and maybe pass on to sort of the core dev teams if they're not here, which is there are some specific things in JavaScript that you might be able to learn from these and from the other vulnerabilities around how to do secure coding. I've seen various shops actually start to use those as internal training as a way to sort of educate their developers around how would they, what types of mistakes might happen, not be offended by them because they happened to really good developers on really popular packages and see how they were addressed in the real world. And then maybe my bigger takeaway is that we should think about open source packages. Sort of the black is the new pink or whatever. OSS package vulnerabilities in my mind are kind of the new unpatched servers as the world, especially with serverless and platform as a service, moves into a world where we're trying to manage servers as little as possible, unless we're at Yelp. This concern, like there's a lot of acknowledgement of the open source binary vulnerabilities, and therefore a lot of these solutions and like ecosystem-wide around how do we tackle them, but there's really no conversation around open source packages, and I think that just would make them the next easiest way for attackers in. It's already a pretty easy one there. Just a bit of a plug, I've got a blog post I posted just today about serverless security vulnerabilities. Welcome to join it. So I would say for those ones, similar workflow to maybe what you're hopefully doing for binaries. You want to find the issues, you want to fix the issues via updates or patches when available. You want to prevent vulnerable package. Don't accumulate this as a technical debt. It's an opportunity to take on a new problem in a modern way, and you want to respond quickly to new vulnerabilities before attackers get a chance to exploit them. And I do want to stress that while I picked on Node and NPM here, this happens in Ruby gems, it happens in Mavens, there's stats and examples for every one of these environments. So that's it. Open source is awesome, but please enjoy it responsibly. Thank you. Do I have time for questions? I think it was supposed to be to 12:50, so I have 4 minutes. Is the mic floating around? A bit.
Just like a very trivial what's the source of the vulnerability information you're using to display the information there?
Yeah, I think the lack of maturity for vulnerabilities also happens in the sort of tracking of the vulnerability a little bit. So for us, we have an open source vulnerability database. It's on snyk.io/vuln, and it's on GitHub, where we kind of sniff GitHub for security-related activities. 2/3 of the issues we inventory have no CVE. People don't understand the need to report those. So we have multiple sources. Some of it is our own research, but a lot of it is just tracking GitHub activities. And recently, increasingly, we're starting to get some reports from people that have identified something. Unfortunately, too often after they've logged an issue, they come to tell us. And GitHub themselves are also conscious of the fact that there's no way to privately report a security issue, and they're considering what they could do around the platform to do those. So we're sort of talking to them about helping provide some guidance. Yes, Denise. Yeah, they can say, and I can echo it back as well.
So how can we then tell if once you have a particular package that has vulnerabilities, how can we tell if our code is actually using those particular methods? Do we get specific information about it's this particular usage or this particular API, this particular thing?
Yeah, no, so it's true. So a vulnerable component does not equal a vulnerable system, and you need to check it. I guess my thesis is that if you make fixing easier than assessing, you might as well just get it out of the way. And to an extent, that's what happens with binaries. You don't, like most of the time, you don't spend the time even understanding what it is exactly that came in. You're just trying to stay up to date. And to an extent, I think that's a more sane approach because you can't expect developers to have, you can give kind of that guidelines around saying, hey, you want to address these vulnerabilities. When you cannot address it, sometimes you're using A that uses B that uses C. C has a vulnerability, but you have no path. Like there is no version of A that would get you to a fixed version of C. Sometimes you can patch it, but if you cannot patch it, you cannot upgrade. You have to have the conversation around assessment, and clearly you should log that. You should track that over time. But in most cases, at least what we try to do is make it so easy to fix that it's easier to fix than it is to have that much more complicated conversation about whether your system is actually vulnerable.
But then that doesn't work very well when you have the features themselves that are the vulnerabilities, right? Or dangerous functionality.
Absolutely.
This is
a slice of security that deals specifically with having vulnerable components. Once you have a vulnerable component to it, there are many paths to using that specific component, and those paths may change over time. So I just think, with the principles of defense in depth, you basically would rather just avoid having the vulnerable component. Yeah. It's not going to address design vulnerabilities. Right now, it doesn't yet capture insecurity faults. So there's more to do there for sure.
And I think it's great. I think it already is a massive sign of maturity in a workflow when you can even use this. Most dev workflows cannot even start to integrate this.
Yeah.
So this
and I think that's a big thesis as well, which is like we built. And I think there's some nascent here, but I think the way to approach it is to think about how would you build a developer tooling set that would help address this problem, as opposed to how do you build an audit tool. As someone who wrote a security, like a static analysis tool that ran in the IDE and was called AppScan Developer Edition, and it was not. It was an auditing solution that was very sort of InfoSec oriented. It was a great tool, but it was not a developer tool in terms of workflow. So, personally, like at Snyk, we're trying to sort of build it from that mentality. And I think anything you build homebrew, you should start from the developer methodology and figure out how do you fit into that versus, like Elizabeth was also mentioned about earlier on. Other questions? Cool. So I'll be here. I'll let you go for lunch. Thank you.